Hello, welcome to part 2 of our basic derivative rules. In the first video, we talked about derivatives and the core concept of it. And in the previous video, we talked about the constant rule, the power rule, the constant multiple rule, and the sum and difference rule. So in this video, we're going to talk about the product rule, the quotient rule, and the chain rule, and how do we solve them. And now for our product rule. It states that if you have a function f times g, then the formula you're going to use, the derivative of f multiplied by g plus f multiplied the derivative of g. How do you know if you need to use the product rule? You need to use the product rule if you have two functions that are multiplied together. So an easy example would be d dx x times x squared. Our f would be the first one, which is x, and our g is the second one that we multiply to, which is x squared. Then you're going to take the derivative of each of those. The derivative of x is 1, and then the derivative of x squared is 2x. And you're going to use these values and we're going to put it in this formula so we can find the derivative of this expression. Now, the derivative of f is 1, g is x squared. We're going to add it to f, which is x. And then we're going to put the derivative of g here. Now we're going to simplify this. 1 times x squared is x squared. X times 2x is 2x squared. Since these variables have the same base and the same exponent, we can add it. So x squared plus 2x squared is equal to 3x squared. Now take note that another way to solve this problem is you can just multiply it directly without using the product rule. So d dx, we just multiplied x and x squared together. Recall that when you multiply, all you have to do is you're going to add the exponent. So that would be x cubed. The derivative of x cubed using the power rule is we're going to put 3 in the front, x, and then we're going to subtract the exponent by 1, which is 2. Which yields the same answer as we did in the product rule. Another problem using the product rule is we're going to try x squared multiplied by 3x plus 1. Now, we're going to find our f, we're going to find our g, we're going to find the derivative of f, and we're going to find the derivative of g. And we're going to put it in the formula, the derivative of f multiplied by g plus f multiplied by the derivative of g. Our f is the first term that we multiply, x squared, and then 3x1 would be our g. Now we're going to take the derivative of both of those. Now we're going to put it in this formula. Derivative of f is 2x, g is 3x plus 1, f is x squared, the derivative of g is 3. Now we're going to simplify those. Distribute 2x to each of these terms. So it will be 6x squared plus 2x. And then we're going to multiply these two. And we'll add it. And then it would be 3x squared. We simplify this further. You notice that these two terms have the same base and the same exponent. Therefore, we can add it. 6 plus 3 is 9. And then we copy the exponent in the base. And then we have 2x. So this is our final answer since it's simplified. Alternatively, you can also solve this using the power rule. We're going to have x squared multiplied by 3x plus 1. You don't have to use the product rule here. What we can do is we're going to multiply x squared with two of these terms. So this would be 3x cubed plus x squared. All you have to do here is use the sum and difference rule and the power rule. So the derivative is, we're going to find 3, which is the constant, and then we're going to put 3 again, x, and 3 minus 1 plus the exponent here, we're going to put it in front, and it would be x, and it would be 2 minus 1. Simplify this, it would be 9x squared plus 2x. It gives us the same answer as what we had here using the product rule. For our quotient rule, it's like similar but different to the product rule. So it states that if you have a function f and the function g, then it would be f, the derivative of f multiplied by g minus f multiplied the derivative of g over g squared. F and g are both functions, okay? An example would be x over x squared. Let's try to solve. So first we're going to get our f, and then we're going to get our g. And then we're going to find the derivative of f, and then we're going to find the derivative of g. Our f is the numerator. The numerator is here above the fraction. The denominator is below the fraction. So what's our numerator? It would be x. Our denominator is x squared. Therefore, it will be put in the g function. Now we're going to find the derivative of both f and g. The derivative of x is 1, and then the derivative of x squared is 2x. Now we're going to put these values into this formula. The derivative of f is 1 multiplied by g, which is x squared, minus f, which is x, and the derivative of g, which is 2x, will be over g squared. G is x squared, and we're going to square that. Simplifying this, 1 times x squared is x squared. Negative x multiplied by 2x is negative 2x squared, and it would be over x. And when you have an exponent raised to an exponent, you just multiply. So it would be x raised to the 4th. Simplifying this further, x squared minus 2x squared, it would be negative x squared, because 1 minus 2 is negative 1. So it would be negative x squared over x to the 4th. And since we can cancel out x squared, the numerator and the denominator, like this, we can just cancel, and we're gonna cancel, and it'll be 1. So it would be negative 1 over x squared. So the derivative of this function is this. Now, alternatively, you can also solve this in a different way. You can cancel out x and the numerator in the denominator beforehand. So it will be d dx 1 over x. And our f is 1, our g is x. The derivative of 1 is 0. The derivative of x is 1. And putting it in the formula, the derivative of x multiplied by g minus f multiplied by the derivative of g over g squared. It would be 0 multiplied by x minus 1 multiplied by 1 over g squared, which is x squared. simplifying this, we can just cancel, and then negative 1 times 1 is negative 1 over the denominator, which is x squared. It gives the same answer as the previous one. Another example for the quotient rule is this one. How do you find the derivative of x squared over x plus 1 using the quotient rule? Our f is the numerator, which is x squared. Our g is the denominator, which is x plus 1, 2x, 1. We put it in the formula again once more. The derivative of f, which is 2x, multiplied by g, which is x plus 1, minus f, which is x squared, multiplied by the derivative of g, which is 1, over g squared, which is x plus 1 squared. Simplifying this, we're going to distribute 2x to both of these terms. 2x times x is 2x squared. 2x times 1 is 2x. Then we're going to distribute negative, so it would be negative x squared multiplied by 1. And that would be just negative x squared. So it would be minus x squared over x plus 1 raised to the second power. Simplifying this, since these two are the same, we can subtract them. So 2x squared minus x squared is x squared. And then we're just gonna copy 2x. And that would be over x plus 1 squared. The derivative of x squared over x plus 1 is x squared plus 2x over x plus 1 raised to the second power. Next, we're going to find the derivative of 3x squared minus 1 over x squared plus 1. This is a little more complicated since the numerator and the denominator are both binomials. Using the same rule, we're going to find f, we're going to find g, we're going to find the derivative of f, and then we're going to find the derivative of g. Our f would be the numerator, which is 3x squared minus 1. Our g would be the denominator, which is x squared plus 1. The derivative of f is 6x, and then the derivative of g is 2x. We're going to put it in the formula once more. The derivative of f multiplied by g minus f, the derivative of g, over g squared. The derivative of f is 6x. G is x squared plus 1. It would be minus f is 3x squared minus 1 multiplied by the derivative of g, which is 2x. And it would be over g squared, which is x squared plus 1 squared. Okay, simplifying this, we're going to distribute 6x to this binomial, which is 6x cubed plus 6x. And then we're going to distribute negative to 2x. So it would be negative 2x multiplied by 3x squared minus 1. So we can distribute negative 2x. So it would be negative 6x cubed. And then we're going to distribute it again. Since negative times negative is positive, it will be positive 2x. And then we're going to go to the denominator and just copy, since there's nothing we can do about it since it's fully simplified. Okay. We can simplify this again since we have 6x cubed and negative 6x cubed. We can cancel both of them. And we have 6x plus 2x. We can add them. It would be 8x. And then it would be x squared plus 1 raised to the second power. And that's the final answer. For the final lesson in this video, it would be the chain rule. Now the chain rule is a little more complicated than the rest of the rules, but once you get it, it's easy to understand. So if you're going to find the derivative of a function with a chain, this is the outer chain, and then this is the inner chain. So basically, this is a function inside a function. So what you're going to do is you're going to take the derivative of the entire function and itself, and then you're going to multiply it by the derivative of the inside function. So this is the outer function and this is the inner function. All you have to do is pretend that the inner function is just a variable, and then you're going to treat the outer function as your expression. So an example of this would be dx 3x plus 2 raised to the 5th power. For this one, you're going to use the chain rule because you can't just multiply 3x plus 2 5 times. That would be so time consuming. So we're going to use the chain rule. How do you do the chain rule? We're going to treat the entire thing as a function. You're going to pretend that 3x plus 2 is a variable. Okay? So what we're going to do is going to take the exponent and we're going to put it in front. So it would be 5 multiplied by 3x plus 2. And then we're going to subtract 5 by 1, so it would be 4. So it would be raised to the 4th power. And then we're going to multiply it by the inner function's derivative. The derivative of 3x plus 2 is 3. So you can just multiply 5 and 3 and it would be 15 multiplied by 3x plus 2 raised to the 4th power. Another example would be x squared plus 1 raised to the 3rd power. And we're going to find its derivative. Again, using the chain rule, we're going to get the entire function and treat it just like how we would use it in a power rule. So we're going to put 3 in the front, and then we're going to put x squared plus 1. Now we're going to multiply it by what's inside the function. So the derivative of x squared is 2x. Derivative of 1 is 0, so we can just disregard it. We can multiply 2x and 3. It would be 6x. And then we're just gonna copy the rest of it, and then it would be fully simplified. And this is the final answer. For the last example of our chain rule, slightly harder, it would be 2x cubed minus x raised to the 4th power. So first we're going to get the derivative of the outer function. We're going to put 4 in the front. We're going to keep 2x cubed minus x, and then we're going to subtract 4 by 1. And it would be raised to the 3rd power. And then we're going to multiply by what's inside. We're going to find the derivative of 2x cubed. The derivative of 2x cubed is 6x squared. And then the derivative of negative x is negative 1. And that's your final answer.